This podcast is supported by advertising outside the UK.
BBC Sounds. Music, radio, podcasts.
Hello, I'm Tom Heap, and this is Costing the Earth from BBC Radio 4. Sewage seems to be getting everywhere. In our rivers, our seas, our media, even our politics. Campaigners, swimmers and ecologists are united in saying that something must be done. But what? Do we need to get tough on the water companies, reform the regulator, pay much higher bills, or all of the above? Let's wade in deep to discover the solution to pollution. Joining me up to their necks in it are, first of all, Alistair Chisholm, who is Director of Policy at the Chartered Institution of Water and Environmental Management. Quick question, how do you describe the state of our waters and kind of what chance of putting it right?
I would describe them as embattled at the moment. I mean, we're going to talk about sewage, but there's a whole raft of other pressures, from farming to forever chemicals to microplastics to the effects of climate change. But the thing is, we know how to fix these things, all of them. It's a case of political will. So we need to demand of our leaders that they actually prioritise healthy waters.
Thank you. We also have Professor David Hall, who's visiting professor at Greenwich University in the Public Services International Research Unit. He was director of that from 2000 to 2013. Same question to you, David.
Our waters at the moment are uncared for and badly managed and underinvested in. What I think is the great hope is the tremendous amount of energy that is being shown by the great public. If we can mobilise that energy behind changing the system to public ownership, we can deliver results which a regulated, privatised system has conspicuously failed to do after a 33-year experiment.
And Professor Penny Johns, who's Professor of Biogeochemistry at Bristol University and specialist in freshwater quality, chaired the government's Water Advisory Group too. State of our waters, Penny?
They're in a really poor state. They are the most depleted biome in the world in terms of biodiversity loss, nowhere more so than in the UK. In terms of hope for the future, yes, we do know how to manage these problems. The issue is that all of those management solutions are going to come at a cost, and that cost involves us as the public. So if we want to resolve these, we're going to have to invest. And the other thing we're going to have to do is have a government who has long sight beyond the term of a single parliament, because the natural environment operates over decadal timescales.
Before we look at how we solve this problem, we really need to know kind of where we are and how we got here. Now, one of the things you hear most often in this story is that sewage gets into our rivers, especially when you get rain. There's this thing called combined sewage outfalls, or CSOs. Alistair, what is a CSO and how does it work, or indeed not work?
So, Tom, we have these sewers which were designed originally in the Victorian times as a single pipe. They take dirty sewage from our homes along with the stormwater from our streets, our roofs and so on into one pipe. What happens when it rains heavily is that as the volume of water in these combined sewers increases, they will go to a sewage treatment works. That has a certain amount of capacity that it can treat. Beyond that point, that sewage has two options. One, it can back up into our homes, or if we have an overflow function, a bit like the overflow in our bath or our sink, it can overflow and it will overflow into the nearest watercourse, and that is what's called a combined sewer overflow.
And I believe in 2022 we saw over 300,000 of those overflows in England alone, 14,000 Scotland, 83,000 in Wales. So it's happening a lot.
It is happening a lot, and they were not originally designed to overflow or spill as frequently as they are doing now. They were only supposed to overflow in unusually heavy rainfall.
Penny, it's not just about these CSOs, or indeed not just about sewage, as in the waste from us, is it?
Yeah, so one of the misconceptions is that what comes out of a CSO is worse than what's coming out of the treated effluent pipeline, which is discharging every single day from every single sewage system. But in reality, the chemical concoction that's present in these is hugely diverse. There are tens of thousands of pollutants in that material, and the vast majority of them are not removed through treatment.
This is really significant because everybody thinks about these pipes that you can see that occasionally flow brown and things like this. But what you're saying is even what is allegedly treated coming out of our sewage works, often that is not good for rivers.
Absolutely. It's the hidden unknown. It's very easy when you're not an expert in a field that you might look at something and you'll see wet wipes hanging off branches of trees and you're thinking, well, that looks really awful. But in reality, what's coming out that's hidden, that's dissolved in that material that's coming out of the treated effluent pipe is significantly damaging ecosystems.
And farming too. We've got fields next to rivers and material can flow off those.
Yes, and that material from livestock also contains nutrients. It contains all of the veterinary pharmaceuticals, the antifungal agents, everything we use to keep the dairy parlours clean.
All these drugs and chemicals, yeah.
Absolutely, along with pathogens. So when you go to a water body, perhaps you're in a bathing water and you've got a problem with E. coli contamination, that may be coming from the sewage works, but it may also be coming from, say, cattle farming. And it's a very significant source of pollution in UK waters.
Right, we've heard about how some of the bad stuff enters our rivers. David, tell me about the structure of our water industry at the moment.
There are two main features of our water system, one of which is positive, which was introduced in 1974 before privatisation, and that is they're regional companies based around river basins, and that should be the best boundary definition for managing the environmental aspects of water and sewerage. So that's a big positive. We got the structure right some time ago. But the big change that is the bigger influence now on what happens was the privatisation that happened at the end of the 1980s. What the Thatcher government did, ironically, the first thing it did was to nationalise water. It took it away from the local authorities, which used to own and run the regional water companies, which is the case in most of the world, and took it into government hands and then privatised them. So what that means is that water companies are now owned by a variety of private investors from all around the world who basically running it as a profitable business. That's what should be expected from privatisation, but it doesn't have the straightforward results that the advocates of privatisation said. In fact, quite often the opposite.
Briefly about the other countries that make up the UK, I gather in Scotland it's still public owned, and in Wales it's a not-for-profit company. Just could you briefly go through those for me?
Yeah, that's absolutely accurate. Some people sometimes say that Water in Wales is run by a cooperative, but it's not. It's a not-for-profit company. Scottish Water is owned and controlled by the Scottish Government, but again, there's the exception here where the wastewater treatment plants are actually also privatised separately under the old PFI scheme. In Northern Ireland, it's still in public hands. So England's the unusual one. Indeed, it's unusual in the world, the way we've privatised our system. We're almost the only country in the world that's actually sold off the entire system to the private companies.
David, thank you. Penny, the biological health, the natural state of our rivers today, winners, losers, probably mostly losers, but you tell me.
So we've got a significant loss of biodiversity across the plant and animal groups that you would see all the way from algae through to the plants, through to the higher animals, fish, and then that has knock-on consequences for the whole of the ecosystem and how that then interacts with, for example, fish-eating birds. So typically what happens in the pollution instance, which we have going on all of the time, the one that is most widespread, which perhaps I'll focus on, is nutrient pollution. So basically nutrients are essential for life. If we don't have them, we can't make DNA. So if we add more, as we do in crop systems, for example, we produce more life, but you get an overstimulation of that in water bodies. So then you'll end up, for example, with algal blooms if you've got a standing water body. In rivers, you'll get filamentous algal growth, and that often is something that's very visible to somebody walking the dog on a Sunday. Well, not just duckweed, but also that kind of brown, slimy stuff you see growing in a feathery way. Then you'll get overstimulation of macrophytes, so that's plants, and that has knock-on consequences in terms of changing the habitat for organisms like water voles, for the insects, and then for the fish that are then feeding on those invertebrates.
In an era of climate change, it's often said that we get heavier bursts of rain. We've got a real problem with quantity. And quantity does relate to quality. You may not immediately associate the two, but having either too much or too little water can add to the problems of water pollution. Dr. Sarah Cotterill is Assistant Professor in Civil Engineering at University College Dublin, and she is a specialist in wastewater.
Water quantity and water quality can't be considered as separate things. If there is a heavy downpour, then more pollutants are going to be washed off into that water body. When we're thinking about sewers and the potential of those discharging through these storm overflows, if there is more rainwater coming into that pipe that is also carrying the sewage, it's more likely to overspill. It's a fixed capacity, and that water has to go somewhere. If we consider the other side of the situation in a drought period or a particularly dry year when we have low river levels, then any pollution incident that might occur would be more concentrated in that river, so it's more likely to have a harmful effect on that river because there's less water within the river to dilute it. One of the ways in which sewage pollution affects rivers is it essentially starves the river of some of the oxygen that's present within there. But when we have low-flowing rivers, there's also less oxygen in them as well because there's less mixing of the water, less turbulent flow. So it again means that the oxygen available for the aquatic life within that river would be, I suppose, doubly impacted by that pollution incident.
Dr. Sarah Cottrell there. Well, before we move on to solutions, just a little bit of kind of how we got to the state that was described by my guests earlier. Firstly, a little bit of a history of water quality, if you like. Alistair, I don't know, can you give me the last, I don't know, let's say 75 years or since the Second World War? Because there were some gains, it seems, and maybe there have been some losses.
When you look back over the years, you know, the UK was obviously one of the leaders in the Industrial Revolution, and at a time when we had big industry, heavy industry, factories in our urban centres, we were very used to hearing about dead rivers that were really badly contaminated with all kinds of industrial pollutants. As those industrial activities declined, then we saw that kind of pollution really fall back. But in the meantime, we've seen growth of our towns and cities, which has resulted in more roads, more hard surfaces off which diffuse pollutants can come, so oils, metals that can wash into our drains. And as well as that, we've seen the emergence of a whole range of new complex chemicals which make their way into our sewage through the way that we consume them. Finally, agriculture intensification and more intensive farming mechanisms which mean that the soil can wash into our rivers. So it's a whole cocktail of things.
And Penny, when I think of our river animals, I mean, I remember doing stories 10 or 20 years ago about the return of otters and the return of salmon, and there was a sort of upbeat feeling about our rivers there. Was I conned?
You weren't conned, but you weren't told the whole story. So I think there's a tendency to focus on the charismatic megafauna. You know, we all know what an otter looks like, I think. And so you can see when they're coming back. And there are particular chemistries that were present in the environment, which we dealt with, which allowed those to recover. And so, you know, we've had those wins with a few species, but there are so many other species out there which are all on the decline, and they might be declining through pollution, or they might be declining through other things like invasive species and the competition for habitat. It's to do with all of it and as an ensemble.
Many people would say that privatisation of the water companies that David mentioned earlier was one of the biggest things to hit rivers. David, could you just explain? I often hear about this thing of them having a lot of debt and taking money out of the system. Can you kind of help me out on what actually happened here?
What people expected to happen was that the regulator would control the company's prices and stop them taking too much out in profit. But what's happened has been that instead of controlling the costs, they've operated a system called incentive regulation. What does that mean? It means basically that companies are encouraged to do things by making it profitable for them to do it. What that system also results in, however, is that companies only do what's profitable for them. And so with leakage, for example, some people may have heard of the idea of the economic level of leakage, ELL, which basically means companies will plug leaks to the point where they're still saving money, but beyond that point, they will stop. And what we end up with is a high level of leakage known as the economic level of leakage. In a sense, with sewage, that's what we've got as well. We've now got the economic level of sewage. This is the level of sewage in rivers which the private companies find profitable. Cleaning it up further is not. And that manifests itself fairly directly in underinvestment in the wastewater treatment plants. There's a couple of recent studies really identified that most of the problems with sewage overflows are coming from around the wastewater treatment plants, even in dry weather. And that is a clear indicator that a big causal factor, in addition to the climatic and population conditions, is a lack of investment by the private companies because they themselves have economic incentives not to invest.
Could you explain to me why and how they've got this debt that they have to service?
Yeah, it's a good question because when we sold the companies to them, we wrote off all the existing debt. Mm-hmm. Between them, they've now got total level of debt of about £66 billion. Why have they built up that amount? Basically, they built it up in order to pay themselves dividends. So the total effect of privatisation on the money in the system available for investment has been a big negative.
We did ask for a response from the water industry about this, and their body is Water UK, and they told us that since privatisation they have invested £190 billion in a sector starved of cash while improving water company efficiency by 70%. They're going to spend a record £56 billion to replumb England, and that would include removing every high-spilling overflow in the country. They also pointed out that they were one of the most heavily regulated industries in the country, in their view. Well, there you go. That gives you an idea of the scale of the problem with pollution in our waterways and the variety of sources. But on this episode of Costing the Earth, we really want to get into what we can do about it. How do we get out of this mess? Is it possible or realistic to have zero sewage in our waterways? Alistair Chisholm from the Chartered Institution of Water and Environmental Management.
I would say, Tom, it's very, very difficult to have zero sewage in our waterways. It's something that campaign groups are asking for at the moment, and quite understandably so. But the reason why there is sewage at all in our waterways is that is how our very centralised system of sewage collection and treatment is configured. Now, we've got northwards of 60,000 kilometres of these combined sewers and thousands of treatment works. To put no sewage into rivers mean you're effectively going to have to replumb all of that. Now, that sits below streets in many of our towns and cities and would involve a huge amount, not only of cost, but disruption to the public. Anywhere between 5 billion and 660 billion has been put forward in a study. Wow. So there's a big margin for error in there. But it completely depends on how far we want to go.
Given the scale of that task, do you, Alistair, think it is plausible to say this is something that can be dealt with by the water companies in their current structure?
I think if they're driven hard enough, what is possible is to reduce those discharges into rivers back down to what most people would probably regard as an acceptable level. And that is really pretty infrequent.
But my point is, even if it's not 660 billion, and I gather some people think that's a contentious sort of scaremongering figure, but given what you're talking about, it could well be hundreds of billions. I mean, do the water companies have enough money in terms of dividends to shareholders? Even if they paid nothing to them, would they have this money?
No, they absolutely don't have the money.
Where would it come from?
Are in debt. It's the customers who have to pay. Ultimately, it doesn't matter how you configure it to get out of the mess that we're in. Either as taxpayers or water bill payers, we are going to be paying for the clean-up. And that's the harsh reality in this situation, unfortunately.
David Hall from the University of Greenwich.
The big difference between having private ownership of the system and public ownership is that you save on the expense of paying out the dividends, of paying higher levels of interest. We've estimated that as saving about maybe £2 billion a year.
If it wasn't privatised, we'd save £2 billion a year, is that your point?
We'd save £2 billion a year that we could use for this kind of investment. But in addition, the big gain, I think, even bigger gain perhaps of public ownership, is that you would finally have a set of regional water and sewage companies that were focused on achieving public objectives. They'd be managed, they'd be controlled by, owned by and accountable to a public who were saying, we want you to do this. We should expect, which everyone else in the world does under public ownership, we should expect our water and sewage companies to address the investment programs and the issues that we want to.
Just briefly coming back to you, Alistair, you said people would have to pay more for cleaner water, I guess, through bills if it's privatised, maybe through tax if it ends up being nationalised. But is there any kind of figure of how much that would be?
Yeah, there has been research on it. I mean, firstly, the average bill in the UK, about £400 a year. Mm-hmm. Now, some of the water companies that have got some of the bigger programmes to do to clean up over the next 5 years, they're suggesting that bills may need to rise by getting on for around £300 in some of those badly affected areas by storm overflows. Nearly double. About 70% of water customers say that they would like to see cleaner rivers for wildlife and they'd be prepared to pay a bit more. Maybe not that much more. You know, we're talking 15, 20% more in terms of willingness to pay, not 75%.
One way of tackling this is to build a bit like they have in London, this massive super sewer that, you know, is a huge bit of concrete. But there are more natural ideas and indeed more home-based ideas. Dr. Sarah Cottrell, who we heard from earlier from University College Dublin, had something to say on this.
Essentially what we're trying to do with nature-based solutions is to mimic what would have happened prior to urban development. So we're trying to restore some of the ability of the land to capture that rainwater. And what this does is it essentially enables that rainwater to bypass that combined sewer network. So instead of having to build a separate system, what you're doing is trying to green the environment so that there is more capacity for water to be stored in the environment.
Give me some examples of what kind of things we might be talking about here.
It could be something as simple as green roofs on buildings. It could be wetlands and ponds at a larger kind of regional scale. Things like permeable paving, which is not typically a nature-based solution, but it allows some of that water to infiltrate into the ground below. And so it still is a compatible technology, I suppose, to use alongside these nature-based solutions.
Why don't we see more of this?
The key problem, I suppose, is down to having adequate data on how they perform. If you've always put in the engineered systems, the engineer who is designing them knows how they perform, how much they cost. It's much easier to write the specification. The other side of it is, whilst they are relatively low maintenance, there are low installation costs, there are low operating costs, there is still some maintenance. It's not put the nature-based solution in and leave it to nature. Sometimes, because these are multi-stakeholder projects, there is confusion or uncertainty around who will own and maintain these assets after they have been implemented.
Penny, we mentioned farming as a problem, and arguably because it's got many more sources, it's hard to deal with. So what would be your suggestion about how we begin to clean up the pollutants coming from farming?
Well, the first thing we need to recognise is that the farmers themselves are not the polluters. In most instances, farmers are not out there deciding to do something that's environmentally damaging. The polluter is actually us, because we're the ones that are demanding food at those prices, and we don't want to pay more for the food that we buy at the supermarket. So farmers are in a very hard place. They'd actually have relatively little profit. And if we want them to start farming in a more environmentally sensitive way, then we need to start paying the environmental damage costs associated with farming in the landscape in the way that we do at the moment. Now,
give an example of how this trickles through. What cheap food ends up polluting a river?
Well, for example, let's think about the dairy sector. So the dairy sector is responsible for contributing huge amounts of organic pollution. It's not only dairy, we're just using this as an example. Pathogens as well, E. coli, all of those are arriving in the watercourse. And the farmers are getting a very, very low price per litre of milk from the supermarkets. As a consumer, we're not paying enough to the farmer for them to farm less intensively with lower stocking densities, which would have benefits for the environment. There's many things that we could do to change the way in which we produce food.
We talked about tricky or possibly unpalatable things when it comes to higher water bills. You're saying we may have to pay A, higher food bills, or B, change our diet a bit here as well.
Yes, I think so. And I think if we genuinely knew what the result was of eating that meal in terms of environmental damage, we might then adjust naturally what we choose to buy and how we choose to consume it. In the same way as we've all moved over to recycling our waste, humanity is perfectly capable of adapting. but most people aren't aware of the costs of what they do. So, for example, there's a tool available online that calculates your water footprint for a single diet. And I often use this for my undergraduate students. And I say, so you leave the lecture theatre, you have a cup of coffee, you have a burger, a bowl of olives and a bar of chocolate. How many litres of water are associated with that production? And when you take into account all of the water that's been used to produce that food and ship it around the world, 7,500 litres of water in one meal for one person. So when people are aware of what's gone into the food that they're consuming, they will make sensible choices within their budget. In terms of the farming environment, what we need to do is we need to hold the water in the landscape for longer. That deals also with our issues with flooding. We also need to hold the soils in the fields. So we need to stop this soil erosion that is transporting many contaminants from the fields into the water body. And if we do all of those things, we will actually hit a multitude of environmental problems that arise from the farming sector simultaneously.
Everything that I've heard today makes me think that this is a very big problem that is going to involve us all in one way or another. Alistair, do you think this is beginning to dawn on folk?
I think where we are at the moment is incredibly powerful in terms of opening up people's eyes to the impacts that we all have in terms of different choices that we make in our lives on the water environment, full stop. How much water we take out of the tap, what we flush down our toilet, what we choose to buy. Everything in a small way has cumulatively a big impact on the environment. And we can only start to tackle this stuff when we really understand it as a society. And I think we're at that point now where we're really starting to get our heads around how big this is.
And David, a lot of the anger we hear is directed towards the water companies. And I'm guessing you'd say a lot of that was justified. Is it just about something that they can do, or does it require a greater level of public engagement to sort this out?
We are seeing a lot more public concern, and it's precisely that to build on. And even with the best will in the world, I think what we've seen demonstrated over the last decade, 2 decades, is that the private companies are not the kind of vehicle that can respond to that kind of public care.
So in terms of ownership, what would you do?
I think public ownership has to be the answer, and it's one that a big majority of the public support.
To find a massive bag of cash, though.
Well, there's also misunderstandings about that too. The companies claim that we'd have to pay compensation of the market value, and that's simply not true.
Professor Johns from Bristol University, do you think we will get some way to cleaning our rivers in the next 10 years or so?
No, I don't think we will. I think it'll take longer than that to turn things around, not only because it takes a while to do these things through Parliament. The natural environment has got an elastic response to stresses we put on the system. So if we decide to turn off the tap now, there are huge pools of legacy contaminants all over the UK landscape. So you're probably looking at decade-scale responses, unless your intervention is very, very rapid and severe.
Well, thank you very much indeed. Alistair Chisholm from the Chartered Institution of Water and Environmental Management, Professor Penny Johns from Bristol University, and Professor David Hall from Greenwich University. I think the one thing we can all clearly agree on is this is a very big project